All right, so we're going to go on to 2.3 factored form of a quadratic equation. I'm going to skip these warm-ups. These are all things that we factored the last couple classes. So we're going to jump right into the first example that says relate zeros to factors of a function. The graph shows the function defined by y equals x squared plus 2x minus 8. How do the zeros of the function relate to the factors? Well, we got the zeros right here, negative 4, 0, and 2, 0. I'm going to go ahead and factor this, x squared plus 2x minus 8. So I'm looking for two numbers that multiply to negative 8 and add to positive 2. So that, of course, would be x plus 4 and an x minus 2. So if we look at the zeros right here, that 0 is negative 4. What do we notice about the comparison of the factors? The factor is x plus 4. The 0 is minus 4. And then this one right here, I've got a factor of x minus 2 and a 0 of 2. Okay, so what can we conclude? Well, we can conclude that factors are the opposites of the zeros. Okay, so these two things are interchangeable. These are things we're going to talk about and discuss throughout the rest of the year. And you need to know that if I give you a factor, you should be able to find the zero. Just like if I give you the zero, you should be able to tell me what the factor is. And the factor is just the opposite of it when we don't have a number in front of the x here. So this is called the zero product property, which all it states is, hey, if I have two numbers that are being multiplied together and the answer is zero, then either one of those is zero. Okay. So all we're going to do in these problems is we are going to factor, and then we are going to set equal to zero and solve. Okay. So looking at these examples, the first thing that we have to make sure, number one, we have to make sure set the quadratic equal to zero. Okay, so it doesn't matter what side you get equal to zero. I'm going to suggest that you keep the x squared positive. So I'm going to subtract 42 from both sides. Now notice I cannot combine this with anything. So it just gives me x squared plus x minus 42 equals zero. Now the second thing that I'm going to do is I'm going to factor. Okay, so we're going to factor two numbers that multiply to negative 42 and add to 1. That would be x plus 7, x minus 6, and that would be equal to 0. And then the third thing I'm going to do is called ZPP, or the zero product property. I'm going to set each factor equal to 0 and solve. So how do I get x by itself? I subtract 7. I get x is equal to negative 7. Here I'm going to add 6, and I get x is equal to 6. So we are now solving equations, and what are we finding? We're finding where the graph crosses the x-axis. Okay, so this problem right here, I'm going to add 9x, and I'm going to subtract 5 from both sides. I have to set it equal to 0. So that would give me a 2x squared plus 9x minus 5 equals 0. And then I'm going to go ahead and do the AC method here. I'm going to multiply a times c. Again, why didn't I do that in this problem? Because there is no a. Here there's an a. So 2 times negative 5 is negative 10. And then I need to find the bx term, which is positive 9. So that would be what? A 10x and a negative x. So I'm going to put in a 2x squared plus 10x minus x minus 5 and set that equal to 0. I'm going to group factor by grouping. So that's going to take out a 2x. It's going to leave me with an x plus 5. Here I'm going to take out a, whoops, I'm going to take out a minus 1. And that's going to leave me with an x plus 5. So the two factors are 2x minus 1 and x plus 5. So this is the factored form. Now I'm going to set each factor equal to 0 and solve. Okay, so I'm going to equal 0. So I'm going to add 1, 2x equals 1. I'm going to divide by 2, and you get x is equal to a half. And then over here, you're going to subtract 5. You get x is equal to positive 5. So if I graph this quadratic in Desmos, it would cross at 0.5 or 1/2 and 5. Notice, I'm not saying that zeros are just always the opposite. They happen to be here when you have a linear factor where a is 1. But in this case, the a was 2. I had to solve it to get the 1/2. Okay, so let's take a look at a couple more examples. Okay, so again, we're going to set it equal to 0. So I'm going to subtract the 20. X squared plus 8x minus 20 is equal to 0. I can just do the puzzle method here because there's no number in front. Two numbers that multiply to negative 20 and add to 8. That would be what? Minus 2 plus 10. And then now I set x minus 2 equal to 0. I set x plus 10 equal to 0. And I solve. Add 2, x equals 2. Subtract 10, x equals negative 10. And again, what are these? These are called zeros. It's where the graph would cross the x-axis. This problem here, I'm going to solve it for 0, set it equal to 0, so it gives me a 2x squared minus 3x minus 2 equals 0. I'm going to do the AC method. Two numbers. Actually, this one I'm going to do the guess and check. I showed it on that other video. If you don't know that, then you should do the AC method, but this would be a 2x and an x. Then I need two numbers that multiply to negative 2. Well, that would be a minus 2 and a plus 1. And again, I check the outer. That's a minus 4. Plus the inner, that's a plus 1. And that equals negative 3. So now it's factored. I'm just going to set 2x plus 1 equal to 0 and x minus 2 equal to 0. I'm going to solve for x. So 2x equals negative 1. Divide by 2. And you get x equals negative 1/2. That's one of the zeros. And then here I'm going to add 2. And you get x is equal to 2. That's the other 0. So again, this is why we needed to spend all that extra time on factoring. Got to know how to factor to be able to solve these. Okay. I've got a couple other slides here. I'm going to stop this video so it's a little bit shorter. We're going to take a look at some word problems here.